All right, students, we're going to show some video of pictures that you should have in your notebook from today's lesson. Um, this is when we were practicing making ratios and equivalent ratios, and then changing them to a fraction, and then to a decimal, and then we shaded in, and then you made it a percent. Don't forget, when you're making a fraction, a decimal, it has to be a base 10, which means it has to be a 10, a 100, or a 1,000, so on. And when you're making a percent, it has to be a fraction that's over 100. It has to be out of 100, or the ratio that has 100. So this is what we did today in class, and so here are the examples that we did together. You can fill in your answer sheet if you were in class and missed something, or if you were absent. This is the second page, and this is where we discussed that a percent is a part to a whole, not a part to a part, and that all of these are equal to each other. Are fractions, the simplified fraction, the decimal, and the percent. They're all in the same family, and they're all equivalent to each other. They just look differently. One thing else that we talked about in class is that the percent sign actually makes a 100. There's your slash, which equals the 1. And then each of these zeros from the percent sign come over to make the 100 that you see right here. And here's something else that we wrote down. If you're changing a percent to a decimal, and we talked about the L, then you're moving it 2 places to the left, the decimal. And if you don't have a decimal, it's always in the back. If you're changing a decimal to a percent, you're moving that decimal 2 places to the right. So that's how we can interchange between percents to decimals and decimals to percents. We also did this page together where we move the decimal to the left because we're doing decimal left 2 places. And if we're making a percent, we're turning that decimal 2 places to the right. What if we don't have a fraction that has 100 on the bottom? Then you need to try to get 100 on the bottom. We did 4/5, but you can remember our fabulous fifth song, 2, 4, 6, 8. Who do we appreciate? The fifths, the fabulous fifths. So 4/5 would be 0.8, which is 80%. We would make this over 100. 2, I did the division here to show that you can divide, but you could also have changed 2 to 100. And 2 times 50 is 100, so I do 3 times 50, which is 150. So that is also why it's 150%. Now with the 3/8, it was a little bit more difficult. There is no way to make that 8 a 100. You can't simplify it to get it to 100, to get it a number that would be a factor of 100. So you have to divide. And something we discussed today in class is a fraction is a division problem waiting to happen. Make sure whatever's on top goes in the box, top box. It rhymes, so it helps you remember where to put the numbers. This is one with a number line. We didn't get to this in all my classes, but you can be filling it in on your paper by pausing the video, and you can be filling it in. This was another page where they just had a little bit more information about ratios. Matching percents, fractions, and decimals is a memory game for this, that you can play with those cards that are right behind this lesson. They have cards with some decimals and percents and fractions, and so you can play a matching game, and here are the answers, so you can check yourself. You can cut them out and put them upside down and play memory and see if you got a match or not. Hopefully we'll get to play this maybe by the end of this week. And that's pretty much it. Now we have your homework. You do not have to do the right. But this practice part looks a little bit like that one with the number line that we had on our practice pages that you were supposed to pause the video and fill in if you needed to. So you want to I'll do the first one. It looks like they cut this whole up into fifths because it goes 1/5, 2/5, 3/5, 4/5, 5/5. So we have 1/5. I can remember my fabulous fifths to make the decimal. So it would be 2, 4, 6, 8. Who do we appreciate the fifths? The fifths, the fabulous fifths. And so 1/5 would be the first one. So it would be 0.2. Okay. But you could have also changed the 1/5 to be equivalent to 10 or 100. 5 goes into 100 20 times. You do the same thing to the top, so you get 20 over 100, or 0.2 or 0.20. If I change it to a percent, it needs to be the one that's over 100. So it would be 20%. So then you would do the rest of them, where you write the fraction, the decimal, and the percent for each place on the number line. And so I did the first one for you. The next part, it says you're just doing the same thing. You're writing it as a ratio. So the ratio for 3 over 20 would be 3 to 20. Is that the only ratio I could do that's equivalent? No, you can make it over 100, or you can make it out of 100. That might be a good idea if you're changing it to a decimal and a percent. So how does 20 become 100? By 5, do the same thing to the top. So 3 times 5 is 15. And now I know it's 15 out of 100. So when you write that as a decimal, it would be decimal 15, and the percent would be 15%. Again, if you're doing percent, you just move that decimal 2 places to the right. So you need to do the rest of them. They give you a hint to help you solve all the other forms in each of these. Now this one's going to be tricky, number 2, because you have to make it a fraction, which will be 3/8. But to make it a decimal or a percent, it's got to be over 10 or over 100, which 8 does not go into a 10 or 100, so you're going to have to divide. Remember, whatever is on top goes in the box. So you're dividing 8 into 3, and that will give you your decimal. Remember, 8 goes into 3 0 times. Place your decimal, bring it up, and add a 0. How many times does 8 go into 30? 2 times. You get 16. Oops, sorry. My bad. 3 times. My pen, my Apple pen died, so I'm having to use my finger, which is not doing a good job. So 8 times 3 is 24. You subtract, you get 6. Bring a 0 down. 8 goes into 60. 7 times. And you get 56. Subtract, you get 4. Add another 0. 8 goes into 45 times. So this would be your decimal. Now, don't forget, when you do percent, you move that decimal 2 places to the right. So it should be, I'm going to let you figure that out. You can figure that out for your homework tonight. You're just moving the decimal 2 places to the right. You might want to write right up here. Okay. On the back, the stretch you can do for extra credit. And this part, don't forget, this is, I would make a fraction. It says that she can make 45 yards. And how many dresses? She said 45 yards equals 5 dresses. So for question A, this is like what we did on our topic 1 test that you guys just got back on the green paper. You would make an equivalent fraction with 18. Where are you going to place the 18? Are you placing it on the top or on the bottom? Remember, it says 18 yards. It should go on the top, because you want to keep your yards with your yards and your yards. Now you got to think to yourself, how did 45 go into 18? How did 45 go into 18? Well, 18, maybe I can simplify this. That might make your life easier. What if I simplified 45 and 5? Well, divide it by 5, and this would be 1, and this would be 9. Ooh, 9 can go into 18. How many times? 2. So what's 1 times 2? 2. You can make 2 dresses. You do not need to create the double line if you don't want to. Remember, B is very similar. C is you're going to be writing each point that's on the graph as a ratio, and you're going to be doing it in this order, so pay attention to the labels on your graph. Numbers of pairs of stockings to the total cost. So I know for the first point, it would be 1, 2, 6. I go from 1, I go over, and that falls right about 6. So that would be the first ratio for the first dot. You have to do the second dot, the third dot, and the fourth dot as a ratio. So you should have 4 ratios. D, ask you a question. Remember, if the ratio is a proportion, the diagonal should continue. Whoops, I didn't do a good job with that. In a straight diagonal line if it is proportion. So if it doesn't fall on that line, then you know it is not the correct ratio. It has to fall in that diagonal. Number 2, A and B, you should know how to do division. And that's pretty much it. Again, let's review and recap. Remember, you can have a ratio, which could be equal to a fraction, which could be equal to a decimal, which can be equal to a percent. Okay, so they're all equal. I'll just put A over B here. Equal to each other, or can be converted into each other. So if I did 3 to 12, that can be equal to 3 over 12, which could be equal to 1 over 4. Simplified, what would that be as a decimal? Well, again, as decimal, it's going to be over a 10, which 4 does not go into 10, or it can go into 100 or 1,000. 4 does go into 100 25 times. Same thing on top. So what would that be as a decimal? 0.25, which as a percent, you move that decimal 2 places to the right, so it would be equal to 25%. So all of these are equal, even though they look different. We have a ratio, a fraction, a simplified fraction, a decimal, and a percent that are all equivalent to each other. And don't forget, when you're going from a percent to a decimal, you're moving that decimal 2 places to the left. When you're going from a decimal to a percent, you're moving that decimal 2 places to the right. Decimal left, percent right. Well, guys, I hope this helped you, and I look forward to seeing you guys tomorrow, ready to go with your pages completed, 121 and 122. Have a good night.